All right. 3, 2, 1. All right, the rest of 1, 2, here we go. Let me give you, this is still function analysis. Part like 20 million. No, but I do feel like we've been doing it for a long time. Let me give you a picture. I think it's easier if I give you a picture of a graph. And let's talk about what we see. Tell me what you notice about this graph. It's wavy. What about the waves, though? That's a good thing, though, the waves. High and low. You're exactly right. Can you believe it? High and low. High and low. So what's another word for, let's say, high and low? Min and max. How many, what do you say? What's another word? Or actually, what would those be? You said min and max. What would those be? A max. That's right. I feel like we've talked about this, have we? We've talked about relative and absolute? No. Okay. So we have two kinds of maximums, two kinds of minimums. We have what we call relative, and we have what we call absolute. Relative means, yes, it's a high point. It's the top of one of those waves, like Miranda says, wavy. But it's not absolutely the highest point on the graph, okay? So that would be what we call relative. If it is the highest point on the graph, there's no other point that goes higher anywhere. It's what we call absolute. It is absolutely the highest point on the graph. Does that make sense to you, the difference there? All right. Arrows never count. Don't ever count those as a maximum or a minimum. That just indicates to us it goes down forever, okay? So you said it had some waves and it had some highs and lows. Where are the lows or the lower? Right in the middle. It's another word for a low. A minimum. It's okay. If I asked you, is that minimum in the middle absolute or relative, what would you tell me? So it is absolutely the lowest point anywhere on the graph? No. Is this point lower than that? Yep. So it's relative. You did know that. Now, it does not have to have an absolute anything. It doesn't have to have relative anything, okay? But if you have an absolute, you can't have more than one absolute. There can only be one absolute. All right? We talked, last time we did this lesson, whatever day that was, we talked about increasing and decreasing, right? I'm not losing my mind, am I? Notice what happens here. What's the graph doing? Is it increasing or decreasing? Increasing until I get here, and then what happens? It starts decreasing. What is happening at these maximums or minimums? It's what? And so what is that pattern? What's it doing? But you're right. It's going from up to down. It's changing direction at those. And so sometimes we call it a change of direction or an inflection point, okay? Or a turning point is another good. Why might it be called turning point? Come on, Miranda, you can get this one. Why might it be called a turning point? It does. It turns. It was going up, it turns, and it starts going down. Right? Up and down. Does that make sense to everybody? All right. These are what we call extrema. So if I ask you to identify the extrema, I'm asking for maxes and mins. All right, let's look at one. That one was easy because I gave you the graph. What if I give you the equation? This is where it's going to get a little bit harder. You're going to need your graphing calculator. All right. Let's graph this, and let's see what it looks like whenever we graph it. So y equals... Now we've calculated the zeros, right? I know we've done that because we solved by graphing. So let's put this in the calculator. Y equals x to the fourth minus 7x squared plus 6x. I'm going to do a zoom 6. We're going to actually calculate these extrema. Now, what do you notice about my graph? What's it look like? Looks like I'm missing something, right? What do I need to see more of? Where? The bottom. Which axis looks up and down so that I can see more bottom? The X or the Y? The Y. If you hit that button that says window, okay, see my Y right now is going down to -10. I'm going to take it down even further than that. Let's take it down, let's say -20. And hit graph again. Oh, I still can't see it all. Did you say 30? I'm sorry. We'll try Miranda's -30. You got to press window and change that. Negative. All right. Now I can see everything. Does everybody's graph look like this? Because if you can't get this, you can't get the extrema. Everybody good? All right. I see some extreme points, and we'll look at the zeros first. How many zeros do you see? What's a zero? Remind me what a zero is. Places where it does what? It crosses the x-axis. That's exactly right. I see 1, 2, 3, 4 zeros. Do you see them all? Oh, I got 1, 2, 3. All right. If I want to calculate a zero, tell me what I do. How do you calculate zeros? Second trace, that's exactly right. And what do I choose? 0. Okay, this is just kind of a recap of when we did this. Remember left bound, right bound? Go to the left and hit enter. Go to the right and hit enter, and then enter again. One of those zeros is -3. Okay? But what we're talking about today are the maximums and minimums. Tell me this, how many minimums do you see on this graph? I see 2 as well. The first one, right here, right? Is that one absolute or relative? This one, absolute. It is absolutely the lowest point on the graph. Do we all agree? All right. To calculate that, go back into second trace. Guess which option I'm going to choose. Maximum or minimum. Let's do minimum, number 3. Since we're talking about you do not have to tell it relative or absolute. You'll only have to indicate that for me, tell me what it is. But as far as calculating them on here, you don't have to know the difference. All right. I'm going to take my spider and put it close to where I think the minimum is. It doesn't have to be exact. And then I'm going to go to the left of it and hit enter. You're calculating it the exact same way as the zeros. Then to the right and hit enter and enter one more time. This time I need the x and the y coordinates. So my absolute minimum here is -2.06 and -24.06. Does everybody see that? So if I was asked, what you'll probably be, what you will have to do is I'll give you an equation, I'll ask you to sketch it, label the critical points, and tell me their coordinates. So if I'm here, I've got this graph that kind of does this. And we said this is an absolute min. And the coordinates of that absolute min are -2.06, -24.06. Everybody good? Yes, no, maybe so? Yeah. It might be off for rounding. That's okay. Everybody's calculator might be a little bit. I mean, but when we're talking little, we're talking about like a tenth or a hundredth off, right? Oh, yeah, that's fine. All right, you do this. You calculate this minimum. Is that relative or absolute, by the way? Relative. You calculate that one, see what you get. Let's make sure everybody gets the same thing. All right, second trace and then choose minimum, shall I? All right, so if I go second trace, choose number 3 for minimum. And now I'm going to go over to where this minimum is. Left, enter, right, enter, enter one more time. I got 1.6, negative 1.8 rounded, or negative 1.77 rounded. So what y'all got? One point, here you go. 1.6, negative 1.77. All right. What is this? It is a high, so it's a maximum, and it's relative. It's relative because there are other high points on this graph. That is not the highest point on the graph. What are the coordinates of that relative max? Find them for me. All right, let's see if we get the same thing. This time I'm going to choose maximum. And I'm going to go left. Miranda, are you awake? And I'm going to go right. I'm going to hit enter. I got 0.46, 1.32. You got them? You're not hitting trace, are you?
I don't do that left and right.
You got to do that left and right.
And I got 0.42.
Well, because you're tracing and you're just trying to get as close to it as you can. So you want to do calculate so that it actually goes in and calculates that high or low point. All right, let's talk about symmetry. Okay. All right, symmetry. We got 3 types of symmetry: even, odd, and neither. Okay? Can we just talk about neither? No. All right, first one I'm going to talk about is even. You can do this graphically or algebraically. You can also do it numerically, but we're going to really focus on graphically and algebraically. Graphically, what this means is that the graph is symmetric about the y-axis. Okay, what does symmetric mean? Same on both sides. So that y-axis right in the middle is cutting the graph in half, and it's the same on either side. Can you think of one that we've done a lot of that is symmetric about the y-axis? Yeah, parabolas. If I have this parabola, that's an even function. It's symmetric about the y-axis, okay? So I can look at it. But the way that we're really going to tell is we're going to do it algebraically. Any equation that we have, if we have f of x, right? If you plug in negative x, I should probably write this the other way. If you plug in negative x and you get the exact same thing that you started with, it's an even function. So if you make every single x in the equation negative, and when you simplify, it looks like what you started with, it's an even function. So that sounds like that would never happen, but guess what? It does. Let me show you. What if this is my equation? If I do this, what does my equation become? If you plug a negative x in here for this, right? What does that simplify to? Come on, guys. What happens when you square a negative number? Positive. What do you notice about these two things? See how I ended up the same thing when I simplified? That's how I know that it's even. All right, let's look at odd, and then I'll give you a couple examples, and you can tell me even, odd, or neither. If it's odd, let me show you what it looks like first. Odd is symmetric about the line y equals x. Okay, so it's a little different looking, okay? If you could fold that graph in half over that line, that's where it's symmetric. All right, so graphically a little bit harder to tell, but algebraically, if it's odd and you plug in a negative, everything in the function changes signs, okay? This is what this means. That means every, come on. Everything changed, right? I multiplied by a -1 through. So, for example, this is x to the third. Okay? If I did f of negative x, so I plug a negative x in there, I get negative x to the third. What happens when you raise a negative number to a third power? It stays negative, right? Because a negative times a negative is a positive, and then times another negative is negative again, right? So this becomes negative x cubed. And that's why it's odd. The sign's changed. Okay? Now, of course, we're going to get into some more complex functions. So let me give you 3. One of them will be even, one of them will be odd, and one of them will be neither, but I'm not going to tell you which is which. I want you to go through and try and see if you can figure, oh dear. Oh, my posters are falling. If you can figure out which is which. All right, here's the first one. Look at the first one. I hope you plugged in negative x. When you did, what happened? What does that tell you? It looks exactly the same as I started. It tells me that that is even. Good job. All right, how about the second one? When you plug negative x in for the second one, so negative x squared minus 2 negative x minus 2. The first one becomes positive, right? This one, I got negative 2 times negative x, so plus 2x minus 2. Neither. That's exactly right. Neither. If that first sign, if that had been negative x squared in front, that would be an odd. Or if that had been, no, never mind. You would have had to have had this and this to be an odd. Okay? It all has, it's essentially what it's doing is you're multiplying the function by -1 in front and distributing through.
So the sign and the odd and the sign, all of them.
Everything's different, right? Yes. Unless you're talking about a fraction, in which case everything in the top changes or everything in the bottom changes, not both. Okay. Which brings us to number 3. If I plug a negative in here, this will be negative. That's right. This stays the same. So you're right, it is odd. Because you see the difference here? Okay, if there's no fraction, then all the signs have to change. If there is a fraction, all the signs up top or all the signs down in the bottom. Either or. Okay? All right, that's even and odd questions. So far we've done extrema and symmetry. That's 2 more pieces of analysis that we're going to be looking for. Huh? Asymptotes and in behavior. Yeah. Y'all don't seem so. Let me tell you this. Oh no, it didn't record any of that boundedness. Let me just say it real quick. Bounded above, it doesn't go above a certain point. Bounded below, it does not go below a certain point, and it does not have to have either if it keeps going forever and ever and ever.